Hi. Today we're going to look at angle-pair relationships. So find section 1.5 in your notes. We are going to talk about some vocabulary words. We are going to talk about what the title is, pairs of angles and how they're related. When you typically see this word in, I guess, geometry and math, it's usually referring to how their angles are related or how their measures are related. So angles have degree measures. So the relationship is a lot of times trying to explain things like, are they equal? Do they add to 180? Do they add to 90? That type of thing. There are several terms here that you're going to need to know. Complementary angles is the first one. Supplementary angles is the second one. And I'll kind of highlight as we go. Okay, complementary angles. There are two types of angles, or two types of descriptions or pictures that could represent this. We'll add a small definition here. Complementary angles are angles that add up to 90. So I'll just jot down add to 90 degrees. So they can be adjacent or non-adjacent. Adjacent refers to angles right next to each other. So the word adjacent is defined as sharing a vertex and sharing a side. So two angles that are adjacent have a side in common and they share a vertex. So two angles that are adjacent that are complementary typically look like this. It has that right angle symbol. Non-adjacent just means they're not right next to each other, or they're not stuck together is how I like to look at it. Two angles that add to 90 that are not adjacent are still considered complementary. Supplementary is identical, except they don't add to 90, they add up to 180. Add to 180. So again, they can be adjacent or non-adjacent, right next to each other or not. Notice on supplementary, if they are adjacent, the other side of the angle forms a straight line. Straight angles add up to 180, so this is a straight angle. Now, a special type of supplementary angles that are adjacent are considered a linear pair. So this word is something we will use all the time going forward here throughout multiple units. A linear pair is a set of angles that are along a straight line and they are adjacent. So they are supplementary as well, but they're called a linear pair. Another angle relationship is vertical angles. Vertical angles. So vertical angles are angles that are formed by intersecting lines here, and they are across from each other. So this first example says that angle 3 and angle 6 are vertical angles. They're across from each other. Angle 4 and angle 5 are vertical. They're across from each other. Another property is they are congruent. They have the same measure. So we'll talk more about that later, but I'm going to say they are congruent. And that's actually a theorem that we'll get into. But you can tell by looking at them, they should look like they're the same size. Okay, let's work on the term adjacent, linear pair, some of this vocabulary. Tell whether the angles are only adjacent. Are they adjacent and form a linear pair, or are they non-adjacent? I think I'm going to use my pencil so I can erase and draw on this picture for each example. Angle AEB, so AEB is this angle right here. Angle BED, so B down to E over to D. So this angle here, this angle over here. So are they adjacent? Yes, they are stuck together. They share a side and a vertex. Are they both adjacent and form a linear pair? Yes, I see them along a straight line. They form a linear pair, so they can't be non-adjacent. So they are adjacent, I'm just going to abbreviate a little bit, and linear pair. All right, number 2, angle AEB Okay, same angle here. BEC, BEC. So this angle up top, this angle over to the side. Are they adjacent? Yes. They're stuck together. They share the side, common vertex. Do they also form a linear pair? No. They are not along a straight line. You're missing this angle over here. We said they were adjacent. So number 2 would just be adjacent. All right, number 3, angle DEC. DEC, this one over here. Angle AEB. AEB. Okay, are they adjacent? Well, they have a common vertex, but they're not stuck together. They have all this space is in between the two. So they're not adjacent. So they're not a linear pair. So this last example would be non-adjacent. All right, I want you to try that on the next group. Tell whether they're only adjacent, and a linear pair, or non-adjacent. So I want you to pause the video and try to work through the next one, and then come back and we'll go over it. Okay, 5 and 6. So we got 5 right here, we've got 6 over here. So I see a line that the angles take up. So if you kind of look at the opening here and the opening here, it forms a straight line. So number 4 would be the second one, adjacent and linear pair. Okay. Next one, angle 7 right here, and SPU. SPU. Okay, we've got an issue here with the fact that one angle is inside the other angle. All right, so you cannot have one angle inside another angle and be considered adjacent. Okay, so they have to be like 2 separate angles. You can't have one in the interior of the other. So these are actually non-adjacent. Okay, non-adjacent. So if you're struggling with the word adjacent, you might over in the margin jot down some characteristics or the definition. Adjacent angles share a vertex. They have a common side, but one cannot be in the interior of the other. They have to be kind of their own angle. 7 and 8. We've got 7 over here, 8 over here. So these are non-adjacent. They're not stuck together. They don't share a side. Non-adjacent. Okay, let's go on to complements and supplements. So we said at the top, complementary angles add to 90, supplementary add to 180. 2 angles that are complements have the same property. They add to 90. So if I am given a diagram here where I've got angle 1 and angle 2, I notice the right angle symbol, so this tells me that they add up to 90. So if I am given a 50-degree angle and I want to find angle 2, I'm trying to find its complement. So I can just do 90 minus 50, and so the measure of angle 2 would be 40 degrees. Letter B. I know that this is a linear pair. I've got a straight line, I've got 2 angles that are adjacent. So I want to find the supplement, the measure of angle 4. I want to find the supplement of 105. So what is the angle that when I add 105 to it, I get up to 180? So if you do 180 minus 105, we should get 75 degrees. All right. Okay, let's take a look at one more with complement and supplement. Number 8. All right, number 8 says, an angle is 10 degrees more than 3 times the measure of its complement. Find the measure of the complement. There's a lot of ways to do this, but I feel like pictures often help us kind of process through. So complementary angles, they add to 90. So I'm going to set up a picture like this. I'm going to draw a big right angle. Put a 90-degree mark there. I'm going to add another ray here. So these two are going to be complementary because it's going to add up to 90. And I'm just going to label the angles with expressions. So one angle is 10 more than 3 times the measure of its complement. So one angle is 10 more than 3 times the measure of the other angle. So let's go like this. Let's just pick one of the angles and put X on it because we don't know either, but that one is going to be our kind of our first angle. So I'm going to take this and represent that with an expression here. So 10 more than would be 10 plus. 3 times is multiplication. So 10 more than 3 times the complement, so 3 times x, because these two are complementary. Now I can write an equation. Add this one plus this one will give me my 90. So I've got 10 plus 3x plus x equals 90. So this is the angle addition postulate we just did. We added the two angles together to get the third. So now we have a pretty simple equation we can solve. Combine like terms. I would take away 10, so I would have 4x equals 80. And then divide by 4, looks like we get 20. Okay, find the measure of the complement. So we got to figure out which one is the complement. This angle is 10 plus 10 more than 3 times the measure of the complement. So this one right here is my complement. So because I got 20 for x, then that, if we plug that in, that's 20 degrees. So the measure of the complement is 20 degrees. All right, so that's a little bit more complicated example. Let's look at vertical angles here. So vertical angles are angles that are formed by two intersecting lines and they're across from each other. Name the pairs of vertical angles. So there are 2 pairs and I'm going to name them with the 3-letter angle name. So the angle on the left and the angle on the right are a set of vertical angles. So I'm going to name the angle on the left. I can call it HML, or you could go LMH. So use your angle symbol, HML, and I'll just do comma to show it goes with the other. The other side, I could say JMK or KMJ. So I'll just say angle JMK. Okay, one pair. Second pair would be the top and the bottom. So I'm going to call the top one angle HMJ. Angle HMJ. And it goes with the bottom, angle LMK. And the other property is we know they're equal. Okay, so we will use that to fill in missing pieces. So let's do number 10, since it still deals with vertical angles. So find the measure, or find the values of angles 1, 2, and 3. So I've got 2 properties here. I know that 102 and angle 2 are vertical angles. I also know that 102 and angle 1 are a linear pair. So my relationships there are, if angles 1 and 2 are a linear pair, I know that they're supplementary. And if angles are vertical angles, I know they're congruent. So I can just kind of fill this in around the whole circle. So I tend to always fill the vertical angles in first. So I've got 102 there. And then now I can take 180 and take away 102. So if I do 180 minus 102, I get 78. So if that one is 78, 3 is a vertical angle to it, it's going to be 78. So the measure of angle 1 is 78 degrees. The measure of angle 2 is 102 degrees. And the measure of angle 3 is 78 degrees. All right, I'm going to stop this video and come back with another video. I believe we have 3 more examples.